Okay, welcome to 6.5. This is indirect proof and inequalities in one triangle. So the essential question for this chapter section says, how are the sides related to the angles of a triangle? And how are any two sides of a triangle related to the third side? What you will learn in this chapter section is how to write an indirect proof, list sides and angles of a triangle in order by size, and use the triangle inequality theorem to find possible side lengths of triangles. So let's take a look. Okay, so the core concept for writing an indirect proof, it's also called a proof by contradiction. Step one says to identify the statement you want to prove. Assume temporarily that this statement is false by assuming that its opposite is true. And then step two, reason logically until you reach a contradiction. Step three, you point out that the desired conclusion must be true because the contradiction proves the temporary assumption to be false. Okay, so let's take a look at one. Okay, so example one, we're going to write an indirect proof. It says write an indirect proof that in a given triangle there can be at most one right angle. So there's the statement we want to prove. So I brought the steps over because they're new. And step one says identify the statement you want to prove. And it says right here, in a given triangle, there can be at most one right triangle or right angle. So we have a triangle ABC. We want to prove that triangle ABC can have at most one right angle. So that's step one. We identified the statement we want to prove, and we're going to assume temporarily that this statement's false by assuming that its opposite is true. So what I want to say is we're going to assume triangle ABC has two right angles. Okay. We're trying to prove that at most it has at most one right angle. So we assume the opposite. Okay. And then we're going to reason logically until we reach a contradiction. So here's our assumption. And so what does that mean? A triangle ABC has two right angles. Well, then we can say the measure of angle A equals the measure of angle B equals 90 degrees. Okay, because we're assuming that it has two right angles. So let's just say A and B are the two angles that are right angles. So now that we have said that, well, we have a triangle sum theorem that says the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. All triangles add up to 180. Well, if we're going to assume A and B are 90, then we can substitute that in. 90 degrees plus 90 degrees plus the measure of angle C equals 180 degrees. Well, if I combine my two angle measures, I get 180 degrees plus the third angle, the measure of angle C equals 180 degrees. Subtracting 180 degrees from both sides, I get the measure of angle C equals 0 degrees. Okay, so there's my contradiction. Whoops. Okay, so since the measure of angle C equals 0, the subtraction property of equality, the triangle cannot be an angle measure of 0 degrees. So this contradicts our given information. And so the assumption that triangle ABC has two right angles must be false, which proves that the triangle ABC has at most one right angle. Okay, so then down here I could say, therefore, triangle ABC must have only one right angle. Okay, so there we go. We proved it. by contradiction. That is an indirect proof. Okay, so that's proof by contradiction. Okay, example 2, relating side lengths of an angle measure. It says draw an obtuse scaling triangle, find the largest angle and longest side and mark them in red. So the first thing I'm going to do is draw an obtuse scaling triangle. So here is the base angle, or the base, the base. And then if I just draw this like so, and come over like that, you just want to go beyond this end to make it greater than 90 degrees. So if I were to stop right here, it would have been a 90-degree angle. And if I were to stop before, then that'd be acute. As if I go out beyond like this, that is an obtuse triangle. Okay, so there's my obtuse scaling triangle, which means all three sides are different in length. Okay. And then it says find the largest angle. Okay, so if I take a protractor now and make it a reasonable size, there we go. And if I put this right here, this is on 0. This angle right here is 27 degrees. Okay, so I'm gonna mark that. This is 27 degrees. Then if I take my protractor, rotate it around, and put this right here, as close as possible to 0. Okay, right there, it's 0. And then I come over here, well, here's 30, 29, 28, 27, 26 degrees. So this is 26 degrees. Okay, and then finally, put it back here so that this is 0. Then I come out here and this is 127 degrees. So this is 127 degrees. Okay, and so I'm just showing you that those three angles are all different, and this is the largest angle, and it says to mark them in red. So now I'll get my highlighter, make it red, and this is the red angle right there. Okay, and then it says to find the lengths of the sides and find the longest side. Okay, so I'll use centimeters. This one is 4.2. Okay, I just made this up when with the ruler. This is 4.2 cm. Move this here. Rotate it. This is 4.123, so it's not the same length. There's two sides that are different. And obviously this side over here is going to be longer because it's the longest one. And that's 70.7. Okay, and then it says to mark the longest side in red. And there it is. Whoops. Okay. So that was the first thing they wanted us to do. It said to find the longest side and mark and the largest angle and mark them in red. Then it says to draw an obtuse scaling triangle and find the smallest angle and the shortest side. So let's do that again. I'm just going to copy the triangle over. Okay, so all I did here was copy this over. This triangle is the same, and then I'm just going to slide it over here. Now, obviously, if you're doing this on paper, you have to do it. again. Can't just copy something on paper. All right, so anyway, we know this is, oops. Okay, let's try that again. What in the world? This is 27 degrees. This is 26 degrees because it's the same triangle. This is 127 degrees. This is 7.7 cm. This is 4.3 cm. And this one was 4.2 cm. Okay, and now we're going to mark the shortest side and the smallest angle. Okay, so 4.2 is less than 4.3 is less than 7.7. So it is right here. There's the shortest side and angle 26 right here is my largest or smallest angle. And it says, what do you notice? Okay, well, if you look at this, 127 degrees was the largest angle, and the side opposite is the longest side. The smallest angle is here, and if we go over to the opposite side, that side is the shortest side. So the angle measure determines the side length. So for instance, let me just say a little bit more here. If I took this triangle here, and instead of having this side right here, and I drew a side out like this instead, okay, this is obviously greater than 26 degrees. So in order to make this angle bigger, this side's got to get longer to reach over to here. So the larger the angle, the larger the side opposite. So if I move this all the way over here now this is going to be my largest angle. Now it's obtuse, and therefore I would have to have made the opposite side much longer for it to reach over to here. All right, so that is what we were trying to point out in this example. The longest side's opposite the largest angle. The shortest side's opposite the shortest angle. So obviously, by elimination, the middle length is going to be opposite the middle sized angle. Okay, so before we do any examples, we're going to look at a theorem. So we're just setting ourselves up to understand what's going on with side lengths and angles measures. So theorem 6.9 says triangle longer side theorem. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if I look at this first triangle here, AB is 8 and BC is 5. So obviously 8 is more than 5. So since 8 is more than 5, then angle C, since it is opposite angle 8 or side AB, which is length 8, angle C is greater than the angle that's opposite the shorter side of length 5. So 5 is opposite angle A. So I'm going to put 2 marks here to make it look like, it's larger. So since this is 8 and this is 5, this angle's bigger than this angle because the angle opposite the larger side is larger. So that's what this says. Side AB is greater than BC. 8 is greater than 5. So therefore, the measure of angle C has to be greater than the measure of angle A. Okay? And then 610, triangle larger angle theorem. If one angle of a triangle is larger than another angle, so here the measure of angle A is 50 degrees. So I'll put 2 marks there. And the measure of angle C is 30 degrees. Since one angle is larger than the other, then the side opposite the larger angle is longer. So BC is longer than the side opposite angle C, which is AB. So if the measure of angle A is greater than the measure of angle C, 50 degrees is greater than 30 degrees. So therefore, side BC, right here, I'll put 2 marks here, is going to be longer than AB. Okay, so that's longer side theorem and a larger angle theorem. Okay, example 3, ordering angle measures of a triangle. So they gave us this diagram. So what I did was I took the triangle that is supposed to be a mountain and I moved it out. I copied it and I brought it down here for us. Okay, so it says you are constructing a stage prop that shows a large triangular mountain. So this is for a stage. The bottom edge of the mountain is about 32 feet long. Okay, so 32 feet. The left slope is about 24 feet long, left slope. Okay, so that's over here. So that's 24 feet long. And the right slope is about 26 feet long. So that's the right slope. So there it is, marked up. Base 32 feet, left slope 24, and the right slope 26 feet. It says list the angles of triangle JKL in order from smallest to largest. Okay, so what I'm going to do is 24 is less than 26 and 32. 24 is the shortest. So list the order from smallest to largest. Be careful with that. If it said from largest to smallest, then you have to start with the biggest. So be careful with how it's worded. So we want to go smallest to largest. List the angle measures of this. So 24 is the shortest side. Okay, so by the angle theorem, we can then state that this angle opposite the smallest side, or it's actually the, what do they call it? The longer side theorem. Okay, since this is the shortest side, the angle opposite is going to be the smallest angle. So listing the order of the angles from smallest to largest would be angle L, comma, and then I'm going to highlight this side is 26 is the next smallest, next largest, and this is the longest side. So the angle opposite, the middle is angle J. So then we put angle J, comma, and then finally we have the longest side. And since we have the longest side last, the side or the angle opposite the longest side is angle K. Okay, so we just listed the angles of triangle JKL in order from smallest to largest. Okay, and that's all you do. So there's example 3. Okay, I forgot to tell you what problems to do with each example. So this is example 3, so now you should be able to do numbers 11 and 12. If I go back to example 2, that is for problem number 9. And if I go to example 1, you should be able to do problems 3 and 4. Okay, so sorry about that. Okay, example 4 is ordering side lengths of a triangle. List the sides of triangle DEF in order from shortest to longest. Well, we know the angle D is 51 and E is 47. 47 is less than 51, but they did not tell us what F is. So to start this, I want to use the triangle sum theorem to find F. So I'm going to say the measure of angle D plus the measure of angle E plus the measure of angle F equals 180 degrees. And then substitute my givens. D is 51 degrees. E is 47 degrees. Plus the measure of angle F we don't know equals 180 degrees. Combine like terms. 7 plus 1 is 8. 5 plus 4 is 9. Plus the measure of angle F equals 180 degrees. Subtract 98 from both sides. And we get the measure of angle F equals 2 and 8. This is 82 degrees. Okay, so by the triangle sum theorem, we found F, and now we can list them from shortest to longest. So angle D is 51, E is 47, F is 82. So always go back and it says shortest to longest. So I want the smallest angle. Okay, so the smallest angle is 47 degrees. So that's angle E. The side opposite angle E is DF. So I'm going to say DF, comma. Okay, and then I'm going to erase this so it's not all cluttered. And then the next largest angle is angle D, which is 51. The side opposite 51 is FE or EF. So then I'll just put EF. So DF and then EF. And then obviously the last one is by elimination. There's only one side left. Okay, so opposite the 82-degree angle, which is the longest side DE. So listing the side lengths from shortest to longest are DF, EF, DE. Okay, so that's how you do it. And now you should be able to do problem numbers 13 and 14. All right, another theorem. Theorem 6.11, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I take AB plus BC has to be longer than AC, and that's what they state right here. Okay. And if I take AC, the green side, plus BC, the blue one, those two have to add up to more than the third side, AB, and that's this one. And then finally, side AB plus side AC has to be greater than side BC. So if you take any two sides of a triangle, the two lengths that you add up have to be greater than the third side. So for example, if this was a length of 3, and this is a length of 5, 5 plus 3 is 8. AC can't be 8 or more. It has to be less than 8. So that could be 7. It could be 6. And there's actually a way to find out how short it can be as well. And we're going to take a look at that in a moment. All right, example 5 says finding possible side lengths. A triangle has one side of length 14. Okay, so here's a triangle. I'm going to highlight that. Length 14, and another side has a length of 9. Describe the possible lengths of the third side. So there are two scenarios here. You can have a small value for x. So in this situation, what we're going to do is we're going to take this theorem right here and say the sum of two sides has to be greater than the third. Okay, so if I say this side here plus this side here, these two sides, we're gonna leave the larger value alone for now. Remember, if this is 14 and this is okay, anyway, 14, 9, and we don't know the third side, we can say x plus 9. By definition, these are the two sides we chose. The sum of the two sides we chose has to be greater than the side left over. So x, this side, plus 9, this side, has to be greater than, these two added up have to be greater than 14. So that's what I'm saying here. So then to find x, I just subtract 9 from both sides. Okay, so then x, 9 minus 9 is 0, is greater than 14 minus 9 is 5. So I know x cannot be 4, it can't be 3, it can't be 2, it can't be 1. That'd be too short. And sides with this length, these lengths could not reach if you go less than the length of 5. So the smallest length for x would be a little more than 5. Could be 5.1, 5.2. Okay, but you can't just say, well, it could be 100, because it can't. Because then here we're going to have another scenario where you have large values of x. So now what I'm going to do is I'm going to take the two sides that we know and add those up. So take 14 plus 9. this side plus this side has to be greater than that side. And 14 plus 9 is 23. So x has to be less than 23. So notice it says 23 is greater than x. Well, you can rewrite that as x is less than 23. So now if I have x is greater than 5 and x is less than 23, I can do that as a compound inequality and say x is between 5 and 23. So this is whoops, what did I do? Redo, whoops, redo, put that back. All right, I'm back. So this is our answer. This side here, notice these two triangles. If you have two sides of a triangle, 14 and 9, the third side has to be between 5 and 23. Can't be more than 23, can't be less than 5. Okay, so there's a shortcut to doing this. Okay, smaller values of x. So the easier way to prove this or show this when you're asked to do this is just simply go 14 minus 9, 14 plus 9. And the two values you get are your minimum and maximums. So 14 minus 9 is 5, 14 plus 9 is 23. And you know, x is between those. That's the easiest way to do it. And that's how I usually have my students do it. So if you could just do this, that'd be great. 14 minus 9 is 5, 14 plus 9 is 23. And so always do the minus on the left, plus on the right, because you want the larger side on the right when you do your inequality. Okay, so now you should be able to do problem numbers 17 and 18. Okay, so that brings us to the end of exercise 6.5 or chapter 6.5. And here are the exercises that I wanted you to do. And 50 to 53 are review questions. Thanks for watching and have a great day.